today's goal of this lecture. Today I will see properties of projection matrix. Actually, projection matrix, this topic is very important for higher study, also for competitive exam. At first, say what is the definition of projection matrix? AB n cross n matrix with summation aij equal to 1 where I equal to 1 to n and summation j equal to 1 to n aij equal to 1, then A is always permutation matrix. That means a matrix representation of a permutation is always a square matrix with exactly 1 in each row and column and other element is 0. When each row are exactly 1, also each column contain exactly 1 and other element in this matrix is 0, then this type of matrix is called permutation matrix. As for example, when A equal to 0 0 1 1 0 0 0 1 0, that means here the matrix is look like 1 2 3, 1 goes to 3, 2 goes to 1 and 3 goes to 2. That means permutation is look like 1 3 2. This is the permutation matrix. Here notice each row sum and column sum of the matrix is 1. Properties of permutation matrix. What is the properties of the permutation matrix? In permutation matrix, first property is always row sum equal to column sum equal to 1. And second, determinant of the matrix is minus 1 to the power number of transposition. And third properties is product of permutation matrix is always permutation matrix. Fourth property is every permutation matrix is non-singular. That means rank of the matrix is n and nullity of the matrix is 0. Next property, if S equal to C1 C2 Ck be the product of disjoint cycle such that length of the cycle is r, then characteristic polynomial is summation r x to the power ri minus 1 is length is the r. You will understand this when I will discuss many example, then you will understand this in better way. Matrix A is always orthogonal or unitary matrix. That means A transpose equal to identity. These are properties. Also there are more properties. Other property is eigenvalue r ith root of unity. That means e to the power 2 pi ik over n. 8 properties. A is diagonalizable over complex field, but A is diagonalizable over real field when sigma is either of order 1 or order 2. 10th property, trace of A is number of cycle of length 1. Number of length 1 cycle is trace of A. Properties 11, lambda equal to 1 always eigenvalue. Properties 12, lambda equal to minus 1 always eigenvalue of T sigma. And if there exists a cycle of even number of permutation, then if even number of length of cycle is even number of permutation, then minus 1 always eigenvalue. Consider this matrix This is 1 goes to 4, 4 goes to 3, 3 goes to 6 and 6 goes to 1 and 2 goes to 5, 5 goes to 2. Therefore, the permutation is such type 1 4, 1 3, 1 6, 2 5. Okay, this is the sigma, and determinant of the matrix A is minus 1 to the power number of transposition. Here number of transposition is 4, so this value is 1. Let's see some more example, then your concept would be more clear. Consider A equal to this matrix. Here 1 goes through 3, 3 goes to 1 and 2 goes to 2. Here the characteristic polynomial CA equal to x square minus 1, x minus 1. Therefore, eigenvalue are for this plus minus 1 and 1. I hope my all viewers have understood why properties are very important. Next example, consider this matrix 0 1 0 0 0 1 1 0 0. Here the characteristic polynomial is, at first notice this permutation matrix, 1 goes to 2, 2 goes to 3. This is the sigma. And here only one cycle, so the characteristic polynomial is x cube minus 1. That means the root means eigenvalue are 1 omega square. This is the root of characteristic polynomial. I hope my all viewers have understood why properties are important. 1 always roots of permutation matrix, but minus 1 also only roots when even number of permutation. And notice here the roots are third root of unity. Question, value of n for which a to the power n equal to 1. Here notice a equal to this matrix. Here this is the permutation matrix, 1 goes to 2, 2 goes to 3. Therefore, since this is the 3 order length, so we can tell a cube equal to identity. Next question, let n be order greater than equal to 7 and Aij be n cross n matrix such that I plus 1 equal to 1. This is true for all I equal to 1 to n minus 1. N1 equal to 1 and let Aij equal to 0 for all other I and j. Then we can conclude that A has 1 as an eigenvalue, A has minus 1 as an eigenvalue, A has at least one eigenvalue with multiplicity greater than equal to 2, A has no real eigenvalue. Here A be the n cross n matrix and n is odd order given. Also given I plus 1 equal to 1. And this is true for all I equal to 1 to n minus 1. Also given n1 equal to 1 and Aij equal to 0 for all other j. This is obviously a permutation matrix and the matrices look like I plus 1 equal to 1, that means 1 goes to 2, 2 goes to 3, 3 goes to 4 up to n goes to 1 and the characteristic polynomial is x to the power n minus 1. N is a odd number. And we all of us know in permutation matrix 1 always be the eigenvalue. So 1 always be an eigenvalue. And other eigenvalue is complex number since n is odd number. So let's see the option. A has 1 as an eigenvalue, this is right option. A has minus 1 as an eigenvalue, this is not right. Other eigenvalue here, just complex number, complex root of unity. So this is wrong. A has at least one eigenvalue with multiplicity greater than equal to 2, this is also wrong. A has no real eigenvalue, obviously A has 1 as an eigenvalue and 1 is an real. So option 4 also wrong option. Option 1 only right option. Next question, let M be 2 cross 3 matrices with real entities and T from M to M such that T of x1, x2, x3, x4, x5, x6 equal to x6, x4, x1, x3, x5, x2. Then characteristic polynomial is x minus 1, x to the power 5 minus 1. Determinant of A equal to 1, determinant of A equal to minus 1, trace of A equal to 1. They are given T of x1, x2, x3, x4, x5, x6 equal to x6, x4, x1, x3, x5, x4. Then sigma equal to 1 map to 6, 6 map to 2, 2 map to 4, 4 map to 3 and other is 1 cycle 5 map to 5. This is the sigma, and since here one 5 length circle and one length cycle, so characteristic polynomial would be x to the power 5 minus 1 times x minus 1. So option 1 is a right option. Next question about determinant. Determinant means minus 1 to the power number of transposition. This is determinant of the matrix A. Here number of transposition 1 6, 1 2, 1 4, 1 3. So number of transposition is 4. So these would be minus 1 to the power 4 means 1. So determinant is plus 1 and trace means which map to fixed point. Here only 5 map to 5. So trace of the matrix A is 1. So option 4 also right option. That means option 1, option 2 and option 4 are right option. Next question, tree map from R6 to R6 such that T of x1, x2, x3, x4, x5, x6 map to x4, x2, x3, x1, x6, x5. Then question about characteristic polynomial is A is diagonalizable, determinant, minimal polynomial. Here the map sigma equal to 1 map to 4, 4 map to 1, then here 2 map to 2, 3 map to 3, 5 map to 6. This is the sigma. That means the characteristic polynomial is, here 2 length cycle is 2, that means x square minus 1 whole square, and 1 length cycle also 2, that means x minus 1 whole square. So this is the characteristic polynomial. This is the right option. And minimal polynomial is always LCM of the set x to the power ni minus 1, where I equal to 1 to up to n. Here sigma equal to n1, n2 up to nk. So minimal polynomial would be LCM of 2 is 2 and LCM of 1 is 1. So minimal polynomial would be x square minus 1 x minus 1. But here given x minus 1 whole square, x square minus 1 whole square. This is the wrong option. A is diagonalizable. Few minutes ago I have seen permutation matrix is diagonalizable over the real field if sigma is either order 1 or order 2. Here sigma is order 2 and order 1. So A is diagonalizable. Determinant of A is minus 4. Here determinant means minus 1 to the power number of transposition. Here this is minus 1 to the power number of transposition is 2. So determinant is 1, here given determinant is minus 4, this is the wrong option. That means option 1, option 2 and option 1 and option 2 are right option, and option 3 and option 4 are wrong option. I hope my all viewers have understood what is the permutation matrix, properties of permutation matrix. This type of question actually very important for higher study, also any competitive exam. Today I will stop here. See you soon. Stay safe and stay positive here.